Hello students, next coming to the experiment number 8 part 2, ring counter and Johnson counter. Okay, here also we are using the IC 7495 which we have used in the serial in, serial outs, parallel in, parallel outs combinations experiments. Okay, this is the pin configuration for the ring counter. So here we are using the IC 7495. So here the same, it is same as a serial and parallel in-outs. We have taken the serial input and the parallel inputs ABCD, mode control, ground, VCC, and the outputs Q8 to QD and the clock signal. Here what we will do means the last output QD will be connected to the serial input 1, that is 10 and 1 should be shorted. Okay. So here we are giving the inputs at the ABCD. These are the parallel inputs. So we should give the mode control as 1 while loading the inputs for one type. Okay. So first time the mode control will be 1 to load the datas ABCD. Okay. So after we should do the mode control as 0 to check the output of ring counter. Okay. So at the initial stage mode control should be 1 to load the inputs. Since we are using the parallel inputs, mode control should be 1, and after loading this we will make the mode control as 0 to check the ring counter outputs. Let us consider the input are 1, 0, 0, 0. Okay. So if we give inputs 1, 0, 0, 0 and after loading the inputs we should make the mode control 0, and after to check the outputs of the ring counter, so initially the output should be 1, 0, 0, 0. Okay. This is the parallel out. So after pressing the clock signal, that QA data will be shifted right. Okay. The remaining, that means the data should be shifted right. So here the QA data will be come under QB. So after giving the next clock signal, so that QB will be shifted to QC, and by giving next clock signal QC will be at QD. So in the similar way, by keep on pressing the clock signal, the data will be shifted to right. That is, this is the process of the ring counter. So let us check the output in the trainer kit. So this is the connection of the ring counter. So I have used a 7495 IC and the connections are made. And this is the mode control input. These are the A, B, C, D, and these are the QA, QB, QC, QD. Okay. So first, as I told, to load the data we are using the parallel inputs. The mode control should be 1. Okay. The input we will give here as 1, 0, 0, 0. So after pressing the clock signal, the output should be 1, 0, 0, 0. Okay. So parallel in, parallel out, in the same way we will get the output. So 1, 0, 0, 0 we have given, and the output should be 1, 0, 0, 0. So next, to check the ring counter operation, we will make the mode control as 0 and we will keep on pressing the clock signal. See, the QA is 0 now, QB is 1. So I will press the clock signal again, QC is 1. Next, QD is 1. So by pressing the clock signal, the data will shifted to right in this way. So this is the procedure of the ring counter. See, by keep on pressing the clock signal, the data will be shifted to the right. Next, coming to the Johnson counters, we will call this Johnson counter as twisted ring counter, because here the same connection is done as a ring counter. The only difference is here in the ring counter we did the QD and the serial input shorted. Here in the Johnson counter, so instead of shorting QD and the serial input, we used a NOT gate here. Okay. So that NOT gate will be given to the serial input. That means the data present at the output should be inverted, and that should be given to the serial input. Okay. So this is the only difference compared to ring counter and Johnson counter. So here also we will use the parallel inputs and the mode control and the VCC ground and the outputs clock. Fine. So, as I explained in the ring counter explanation, to set the parallel inputs, the mode control should be 1 first. So, keeping the mode control 1, we will get the data at the ABCD 0000. Fine. By giving the ABCD 0000, we will load the inputs as 0. The output should be 0000. Okay. So, after to check the Johnson counter output, we will change the mode control from 1 to 0. To load the inputs, we will make the mode control as 1. So, next to check the output of the Johnson counter, we will make the mode control as 0. Okay. So, here check mode is 0 here. So, the outputs are 0000. The inputs we have given are zeros only, 0000. By pressing the clock signal and making the mode control 0, the QD value here 0000 is there. That QD value will be inverted as 1 and come to the input QA. Okay. So, next by pressing again the clock signal, the QD will be inverted as 1 and come to the place 1, and the previous value of QA will be shifted to right, the place QB. So, next again by pressing the clock signal, we will the QD value 0 will be inverted as 1 and come to the place QA, and the previous value of QA QB 1 1 will be shifted right, Q1 1. Okay. So, next by pressing the clock signal, the 0 of QD will be inverted as 1 and come to the place QA. And the remaining of QA, QB, QB values will be shifted right. So, 1 1 1. So, again by pressing the clock signal, so QD will be inverted into 0, that is here we have 1. So, that data will be come to the place QA, and the remaining 1 1 1 QA, QB, QC values will be shifted right. So, 1 1 1. So, in this way by keep on pressing the clock signals, the inverted value of QD will be come at the QA place, and the remaining QA, QB, QC values will be shifted right to the QB, QC, QD value. Fine. So, let us check the output in the trainer kit. So, this is the Johnson counter connection. We have used 7495 IC and 7404 NOT gate IC. Fine. So, just we connect the QD to the NOT gate and inverted that QD value and given to the serial input 1. Okay. So, this is the mode control pin, and this is the ABCD, and this is the QA, QB, QC, QD. Okay. So, first as I told, we should make the mode control 1 and we should load the parallel inputs ABCD. So, here I will give the ABCD as zeros only. So, by pressing the clock signals, we will get the zeros. Here zeros are there already. So, we have given the input 0, the outputs are 0. Then next to check the Johnson counter outputs, the mode control should be 0, and by keep on pressing the clock signal, here QD is 0, fine, that will be inverted as 1 and coming to the place QA. Okay. See, by pressing the clock signal, see QA is 1 and the remaining are 0. Next check by pressing the clock signal, here I will press the clock signal. See, QD is 0 and that is inverted as 1 and given to the value at the place of QA, and QA value is shifted to 1, QB place. Next by pressing the clock signal, we should get 1 1 1 0. See, by pressing the clock signal, we should get 1 1 1 0. So, next by pressing the clock signal 1 1 1 1. See, fourth clock signal 1 1 1 1. So, here next for the fifth clock signal, the QD value will be inverted, that is 1 will be become 0 and come to the place QA. That means by pressing the clock signal, fifth clock signal, we will get the output as 0 1 1 1. So, we will press the clock signal, see 0 1 1 1. So, keep on pressing the clock signal, we will get the output like this. Fine. So, this is the procedure of the Johnson counter. Thank you.